All right, guys, welcome to Precalculus 3.2.2, and we're going to be talking about finding the area underneath of curves today. So that's going to be a big topic for pretty much the rest of the year, and it goes into calculus as well. And we're going to initiate that here. So our first problem is we have Erin, and she's driving from Green Bay to Milwaukee, and we're going to go ahead and make a graph based off of her situation here. So what I want you to do is go ahead and pause the video, read through that, try and answer problems A, B, C, and D, and then we're going to go through and talk about those here in a second. So go ahead and do that for me. Okay, so we're going to go ahead and take a look at this. So if we graph her situation, I pull up my document camera, turn that so we can see it better. We have her starting off by going a constant speed of 25 miles per hour. She does that for the first half hour. So it will be constant, so it's just going to be a horizontal line until we're at half an hour or 30 minutes. Right? And then she's going to accelerate at a constant acceleration here until we get to 75 miles an hour, which takes her a quarter of an hour to do. So that will be here halfway between there and there. And then we'll be going up constantly in that region there. Okay. And then she drives 75 miles per hour for the rest of her journey for a total time of 2 hours. So I go over here to 2 hours. I'm going to be going constant speeds. It's going to be a nice horizontal line there. So that would be our graph of her situation there. Okay. So now we want to shade the area under the curve. So I'm going to kind of draw a line down, and I'm going to kind of slowly shade in all of this region. So effectively what we're doing is making a kind of geometric shape here and saying, right, what's going to be the area of this particular shape, right? So for part B, what are the units when calculating the area of this region? Well, let's think about what our length and our width are. Our length is miles per hour. Our width is hours. So it's going to be miles per hour times hour, because it's length times width. So just unit-wise, those hours are going to cancel out. So what I'm left with is miles. So my unit is going to be miles. So the area of this shape is miles, which feels kind of weird because we're used to like area being something squared or things like that. But since those hours canceled, our unit is just miles. So this is why this is a useful thing for us, right? If I find the area of this, I'm going to find the distance she has traveled total. And I can break that up by region if I would like as well. So for part C, calculate the area of this shaded region between 0 and 2. So if I break this up, I can do a little rectangle here. I can do a big rectangle here. And then you can do this as a trapezoid if you care to do a trapezoid, or we can do it as a smaller rectangle and then a triangle there. So let's find those different areas. So this is half an hour times 25 miles an hour. So 0.5 times 25, that has an area of 12.5. So this is 12.5 miles, right? And then this little area here, right? Well, that's a quarter of an hour for 25 miles, at 25 miles per hour. So 0.25 times 25, that's 6.25. Right? Then my big region here, that is an hour and a quarter, or 1.25 hours, and that's 75 in its height. So 1.25 times 75, that has an area of 93.75 for that big thing. And lastly, I need that little triangle there. Well, that's going to be length times width times height. So that's 50 in height. So 50 times, that's 0.25 in width, and then times a half because it's a triangle. I get 6.25 for that one. So then to find the total, I just want to add all of those up. So I'll do my 6.25 plus 12.5 plus 6.25 plus 93.75, and I end up going 178.125 miles there for that one. All right, so then part D, what does the area from 0.5 to 0.75, so the area from here to here, represent, right? Well, that is just the area or the distance she traveled while accelerating in that heavy traffic, right? All right, so let's hop back over here and head to the next slide. So let's go talking about notes here. So area under a curve is a big topic which we're going to be covering. It's all about trying to use that area, not just, hey, here's the area for the sake of it. It's an area of a situation like we just did there. That area was telling us the distance. So the area will often tell us an important variable which we care about for the particular situation. So that's kind of why we're doing this stuff. All right, so looking at number 102. So you don't need the resource page, just kind of graph this on a XY axis in the first quadrant. So graph that and then try and calculate the area. Just estimate it. So do 102 and then do the same thing on 103, and then 104 is kind of a combination of those two things together. Then pause and then come back here. Okay, so now that we're back, let's go ahead and take a look at these graphs. So if I graph these, this is what I end up getting. I'm going to turn this so it looks a little bit easier for me. There we go. So this is my first region, right? So I graph that. Here's my shaded area underneath it. My second region looks like this. Here's my shaded area underneath that. So we're not going over the exact way of how to find the area yet. This is all about exploration and what do you think would be a good method. So what you likely can do is say, well, I can kind of count the number of boxes here. So I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 whole boxes, right? But then I have maybe like half and half, so maybe now we're at 16. Here's like a half, and maybe those two together are a half, so now we're at like 17. Maybe this is like, I'm like saying a little bit under 18, so I'll say I have 17.75 boxes, okay? And each box is a half unit by 1 unit. So if I say, well, 17.75, which was my estimate of number of boxes, times each box has an area of 0.5, I'm estimating about 8.875 as the area of this particular region. Now you might be higher than that, you might be lower than that, but just have some method that you kind of use to estimate that. Some people say, well, if I draw a big triangle here and find the area of that triangle, then add it to the rectangle, that works fine too. So it's a matter of try and find ways to do that, right? If we go over here and do the same thing for 103, I can say, well, I have 1, 2, 3, 4, 5, 6. Maybe these two are 7, and then 8, and then 9. Maybe I have 9 boxes. That's probably a bit much. Maybe I'll call it like 8.7. So I'll do like 8.7 times 0.5, because I have 0.5 per box. Maybe that's 4.35. Again, it doesn't need to be perfect. Mine are by no means perfect. Just try and get it close to what makes sense for you and how you would find it. Another way you could do this is say, well, I could try and find this average area there and this area there for each of those, and then kind of add them all up, whatever kind of feels right for you. So then if I added up my two things together, that would be my approximation for number 104. So I would say, well, 8.875 plus 4.35. My estimate is 13.225. Okay, so our big focus right now isn't, hey, what's the exact answer? And that's why I'm not going to tell you what it is, but there are ways to find that. It's about, well, what's our strategies for finding this? Now there's better ones than what I just showed you. I just showed you what most people do, so that's why I kind of tried to match what I predict you would have kind of done. But there are, again, multiple ways of doing that. All right, so with that, let's change back over to this. We're not going to be doing the closure. just because we already talked about that. But instead, here is our homework for 322. So with that, I'll talk to you guys next time.